So in this video, we'll see how to find the inverse of a matrix, right? So to find the inverse of a matrix, so the first step is to find the determinant value of, right? So for that, the formula is simple. It is, so the first element of the first row multiplied by cofactor of first row and first element plus first element of the second element of the first row into cofactor of the into its cofactor, and the same goes for the third element of the first row, right? So that's what we have done. So that's what we have done here, right? I took the first element of the first row, that is 3, and then to find the cofactor, I'll hide the first element in the first row, and then I'll multiply minus 3 into 1, and then I'll subtract, and then I'll multiply minus 3 into 1, and then I'll subtract it from the product of minus 4 into minus 1 to 4, right? And then I'll multiply it with the cofactor. What is the cofactor? Cofactor is here Cij is equals to minus 1 to the power I plus j into the minor, right? Into the minor. What is the minor? Minor is the product. Minor is what we get when we hide the row and column. When we hide the first row and the first column, and then I'll multiply minus 1 into, and then I'll multiply minus 3 into 1, and then I'll subtract it from 4 into minus 1, right? And so that will be the minor, so this is the minor, and then I'll multiply it with minus 1 to the power I plus j. So minus 1 to the power I plus j into minor, right? So here, this is the first row and the first column, right? So minus 1 to the power 1 will be 1, right? So minor will be multiplied with 1, only. In the second part, it will be multiplied with a minus 1, because minus 1 to the power 1 plus 2 will be minus 1, right? So here it's minus, and the second time I'll hide the row and column of minus 3. I'll multiply 2 into 1, and then I'll subtract it from minus 4 into 0, which I've done here, right? For the third time, it's the same. Similarly, for the third time, just hide the row and the column of 4, right? 4 into 2 into minus 1 minus 3 into 0, right? So when we solve this, I get 1, right? So, and once I get the value, next I'll make a matrix of cofactors of A, right? So I'll take all the cofactors so I'll take all the cofactors, right? So the cofactors is this part, that is minus 3 into that's minus 3 plus 4, so 1, and then the second one will be minus 2, right? Because the minor is 2 here, and then I'll multiply it with, and then I multiply this with minus 1 to the power 1 plus 2, that is minus 1, right? So minus 1 into 2 is minus 2. The third time it's minus 2, which you got from here, so that is minus 2, okay? So similarly for the fourth time, I'll first find the minor by hiding the row and the column, and I'll multiply it with minus 1 to the power I plus j. So minus 1, 3, 3, and 0, minus 4, minus 3. So that's the cofactor of the matrix. So that's the matrix of the cofactor, which will give us the adjacent, which will give us the adjacent matrix of A, that is the transpose of cofactor matrix. So rows will become column, and column will become rows, right? So this is adjacent of A, right? And then A to the power minus 1, that is, so now the inverse of A is 1 by determinant value of A into adjacent of A, right? So I'll take this matrix, so I'll put the value of adjacent of A, and then I'll divide it by the determinant value of A, that is 1, which we found here. So that's the inverse of matrix A, right? So very simple. So it's a very simple process of finding the inverse of matrix. If you have any doubts and suggestions, please write in the comment section, and please follow further videos in the series Linear Algebra.